Welcome to my YouTube channel. So on this video we're going to talk about the exact of differential equation. So we're going to look at the exactness of differential equation. So please, if this is your first time watching my YouTube video, please make sure you subscribe for more videos. So with the exactness, we have something you need to obey. You must first check for the exactness after you proceed. So now we have the partial ordinary differential equation. So with the exactness, you will need to introduce something called the partial differential or the partial differentiation. So if you've watched my previous video on homogeneous of differential equation, you will surely see this equation. So with this equation, the question will be given in this form and you need to arrange it in this form. So with the function of n goes with the x and the function of n goes with the y, which is equal to 0. Then when you are done, you find the partial differential of the m. But the thing is, when finding the partial differential, you need to find the partial differential of m with respect to y and the partial of n with respect to x. So with this, you know that it can be somehow contradictory because with the x is going to the m. But with the exactness of differential equation, for you to check for the exactness, you need to make sure that you will partially differentiate m with respect to y and partially differentiate n with respect to x. Yes. So let's move on with that. So now we are going to look at how we can check for the exactness of a differential equation. So first example is given to us. So we are lucky that this example is already arranged. So we will therefore find our m function and the n function. So as you can see here, since the dx is with this function, this one becomes what? The m function. Now, after you find the dm function, what you do now is you find the partial derivative of this function. Now, when you find the partial derivative of m with respect to y, it means that you are going to just look at the y, but you're not going to touch the s. So therefore, the x become constant, but the y is what you're looking at. So with this, the reason why here is 2x is because when you differentiate y, you're going to get 1. And 1 times the constant, which is 2x, you get 2x. Yes. And let's check for the second one. With the second one, when you differentiate it with respect to x, you're going to get 2x. So this equation or this differential equation is an exact equation, or it's qualified to be the exactness because they have the same word. When you differentiate them partially, they have the same answer. So it means that it is exactness, right? So with exactness, it means that when you differentiate with m with respect to the partial differential of m with respect to y and the partial differential of n with respect to x, you must get the same answer, right? Let's take another example, which is this. So with this, you can pause the video and try it. So now with this, you need to find the function of m and the function of x. As you know, the function of m deals with the x and the function of n deals with the y. So when you check the function of n, the m is 4s sine y. So you are going to differentiate this with respect to what? Y. Please note this. So when you do that, the differential, that's the partial differential of m with respect to y, you're going to get 4x. Note that you're not going to type the x component because you are differentiating with respect to what? Y. And when you differentiate sine y, you're going to get cos y. So let's take the second one. With the second one too, with the n function, we have 2x squared cos y dx, dy. So we are going to partially differentiate n with respect to x. And when you do that correctly, you're going to get the same answer, which is 4s cos y. Because you are not touching the y, we are touching only the x. And when you differentiate this, you're going to get 4x what? That's 4x. So this also is exact because they have the same answer, which shows that this equation is exact. Let's take the third one. With the third one, you can also pause this video and try it. Now with the third one, we already know that the dx moves with the m and the dy moves with the y, the n. So when you do that, you're going to what? Partially differentiate this with respect to what? Y. Note that. So you're going to just touch the y. So when you do that, it means that when you differentiate y, you get what? 1. So you're going to get what? 3x squared. And you take the n and you differentiate it with what? With respect to x, and you're going to get what? 3x squared. It means that this is also what? An exact differential equation. So now we're going to take one example, that is with the exactness. After checking the exactness, what you need to do is you integrate both sides and you what? Add the answers. So let's take this example. So please pause this video and try. Please find the whether this equation is what? An exact what? Equation. That means that when you differentiate partially with differentiate partially each of the function, you should get the same answer. So now with this, we have our m, which is this. So we are going to partially differentiate it with respect to what? Y. And when we do that, you are not going to touch with this. You know that you are not going to touch with respect to y. This what will be 0 and this. So you're going to get 4. And with the 4, when you differentiate for y, you get what? 4, right? Now let's do the second one. With the second one, we are going to partially differentiate with respect to what? X. So when you do that correctly, you're going to get 4. Yes. So this and this are the same. Yes. Let's check something from here. No, you know something? The reason why we have 2x here is that the y is with the what? The 2x. But if they are separately, it becomes 0. But this is not, they are not separate, it's together. That's why the 2x become what? A constant. Because if you do this and the 2 become 0, it can be possible, right? It will make the whole equation undefined. So because they are, it's a product, that's why this become a constant. But when you check the example that we did here, the one we are trying to solve with this example, these are, they are separately, right? The 2x is not with the y, so therefore the y, we are differentiating with respect to x, y, therefore the x becomes 0, and then when you differentiate, you get what? 0, right? That's why you have this, and this to the same thing. I hope you understand. Yeah. So after testing for the exactness, what you now do is, since the equation is exact, the differential equation is exact, you now find the integral. Look at this. You are finding the antiderivative or the integral of the m function, which is this. You are finding the function, that's the integral of this, with respect to x. Note, with respect to what? X. So with this one, when you are partially differentiating, you do it with respect to y, but when you are integrating, you do it with respect to what? X. So when you do that correctly, you're going to get, when you do this, when you're going to take it one, let's take this and what? Integrate. You get what? You get, I think, 2x squared over 2, which the 2 will cancel the 2, leaving you x squared, right? And when you what? Integrate this become a constant. So we have 1. So when you integrate 1, you get x, right? We are doing with respect to what? X. So we had what? 4xy. And when you what? Integrate it, you're going to get what? 2x. Reason it that this x is equal to 0, you add 1. You know how to do that. Plus a certain constant with y as the constant, right? So since you are what? Integrating with respect to what? X, the constant will be what? With respect to y. You do the same thing for the n. And when you do the same thing for the n, you're going to get this, you're going to get 4xy plus what? When you integrate it, you're going to get 3y squared. And when you integrate it, you're going to get 2x plus another constant, a certain constant with respect to what? X, because we are doing it with respect to what? Y. Now, after getting to these two equations, what you do is now you're going to sum them up. Therefore, you take their common one. So with this, they are common. So when they are common, you choose one. So the answer, you're going to get x squared plus 4xy plus 3y squared plus 2x is equal to c. This is because the x 4y with what? Reflect here, and the what? Y squared also reflect. Thank you very much for watching this video. Please subscribe for more videos. Thank you.